Welcome to our last lesson in the exponential functions unit. Just a quick recall for the equation of the exponential growth or decay. We have been working with the equation y equals a and then b to the exponent of x. And in terms of that, we have talked about the a value being our initial value, or the y-intercept, and the b being the rate of growth, or decay, where the b is 1 plus the percent growth, or it's 1 minus the percent decrease. Okay, so the a is your initial value, and the b is either 1 plus the percent growth, or it's 1 minus the percent you're decaying or decreasing by. That's supposed to be a percent sign, decrease. Okay. So we're going to use this concept to help us do some more application questions. Yesterday we were focusing more on the money application, which really is this formula, just some special cases of it. Example 1, suppose you make a long-term investment of $1,000, so that's what you're starting with, initial value, at a fixed rate of 0.08 or 8% per annum, and it's compounded annually. So this again goes back to our compound interest formula. The amount, determine the equation for the amount of money, A, that you would have after n years. Your amount is going to start with $1,000, and then we have our 1 plus, and our interest rate would be 0.08 divided by 1, because it's just compounding annually, which is 0.08. And then n just represents the number of years, and it's only compounding once, so it's 1n, or n as our exponent. All right, so there's our model. Calculate the amount you will have after 6 years. So this is telling us n is equal to 6, and we want to calculate the amount a. So you're just going to sub 6 in for the n, and then do the calculation. So we should have 1,000. 1 plus 0.08 is 1.08. So I've just added those together to the exponent of 6. And then you can put that in your calculator. And I think you get $1,586. And money gets rounded to 2 decimal places, so that rounds to 87 cents. So therefore you will have $1,586.87 after 6 years. Okay, so on your test, make sure you put a concluding statement for that. Now, part C says, how long will it take to have the 1925? Well, the 1925, that is your A value. That's your capital A. The how long will it take? It's the n we don't know. It's what we're trying to solve for. And what we learned in our last lesson is how to use technology to solve for that exponent n. You could always use trial and error, like guess and check, to work out different values, but we could also use our Desmos and put that into Desmos. So my one equation would just be that a, or y, is equal to 1925. I might actually change that. Whoops. Let me see if I can find the right tool here. All right. I somehow added a text box there, and I'm not sure exactly what I did, but I wonder if I can, nope. Oh, there, I got rid of the text box, but then I also got rid of some other things. Okay, let's see if I can find the correct tool that I wanted. Nope. All right, well, one equation would be y equals, so this could be a, or it could be the y. Y is equal to 1925, and then our other equation would be that y, or a, is equal to the 1,000, 1.08 to the n, or to the x, and we can find where those two intersect one another. Okay, so use your Desmos there, find the intersection point, and then you can solve that question. Okay, I used Desmos on that question and I got an 8.51 comma 1925 as my intersection point. So that means after about 8.51 years, that investment will have grown to $1,925. Okay, so make sure you know how to use your Desmos to solve those exponential equations. Again, you could use guess and check or trial and error to find the value of n that would make that a value. So find the value of n here that would make the a value actually equal to 1925 or close to that. Okay, example number 2. Several layers of glass are stacked together. Each layer reduces the light passed through it by 5%. Determine an equation for the percent of light that passes through. Define the variables that you use. So let's think about this. Let's think initially, if you have no layers of glass, what percent of light will actually pass through? So what percent will initially pass through? What's our initial value? Well, I'm thinking the initial percent of light would be that all of it's going to pass through, or 100% of it will pass through, because there are no layers of glass there. All right, so that's our initial value. It's 100 or 100%. And each layer reduces, so our B value, our B would equal our 1 minus the 5%, 0.05. So that's going to give us 0.95 as our B value. All right, so the equation that represents the percent of light, and we're going to define our variables. So I could let P represent the percent of light, or I for intensity represent the amount of light that's passing through. And then I could let N be the number of layers of glass, or L, something like that. But I need some let statements to indicate what each variable represents here. Okay, so given those variables P and N, I would have the percent of light would be equivalent to, our initial percent is 100%. Our B value we already determined to be 0.95 because it's decreasing by 5% per layer, and N is the number of layers that are used. Part B here says calculate the percent, so it's P that we're trying to find. P is the unknown. If there are 7 layers, well, N is equal to 7. So you can just substitute those values into the equation and calculate the percentage of light. Okay, put that in your calculator. And then for part C, how many layers, so it's N, how many layers, N is unknown, would let 75% of the light, let that pass through. So my P is equal to 75. P equals 75. And then I'm going to solve for the N. So when I'm solving for the exponent for part C, I'm going to have to use my Desmos, and or I could use guess and check. The nice thing about this is you can either have a full layer or you don't have that layer. So you can really only work with whole numbers when we're working with N. It doesn't make sense to say you had a fraction of a layer unless you had some kind of a machine that could whittle down that layer of glass into a smaller layer. Okay, I put that into my calculator and I got approximately equal to 69.8%, so almost 70% of the light was still passing through with 7 layers of glass. And then for this other one, I put into my Desmos, I put a y equals 100, 0.95 to the x, and then I put in a y equals 95, and I found the intersection point, and I found that it was about 5 layers was about 77, 6 layers was 73.5. This would have put out a decimal amount, but again, it doesn't make sense. So guess and check makes sense with this one. I know that 70% was at 7 layers, so I could try 6 layers and see what that gives me. 6 layers gave me a percentage of 73.5% roughly, and 5 layers, I tried that one. 5 layers, that gave me a 77.4%. So to let through 75%, we know 5 layers would let a little bit more than 75%, about 77%, and 6 layers would let a little less than the 75%, so 73.5% would pass through.